Hey guys, today we're going to look at some more concepts with trigonometry, and we're going to look at them specifically related to right triangles. Alright, first off, we have this diagram of a right triangle here, and we've got three different sides, obviously, for a triangle. We've labeled them opposite, adjacent, and hypotenuse, and these are very, very important for what we're doing. The opposite side is always the side that does not touch the angle that we're talking about. So if our angle is over here, the opposite side is going to be across on the other side. This side does not touch this angle that I have here. You see we've got two sides that do touch this angle. This is the adjacent side and the hypotenuse. And the way you distinguish between them is the adjacent side is always shorter than the hypotenuse. The hypotenuse has to be the longest side, and it's always going to touch the angle we're looking at. Now, they may not always be in this order. For instance, if I take this and turn this, the angle we're looking at is now up here, and our opposite side is on bottom. The adjacent side is still the angle that touches, or still the side that touches this angle, but it's just moved in position. So if we move the angle around, the sides move with it. So make sure you've got this because I'm going to be talking about opposite and adjacent and hypotenuse quite a bit. Alright, some of you may have heard this phrase, but the phrase Sohcahtoa is what I use and what a lot of people use in order to remember what the three basic trig ratios represent. So what this stands for is sine of an angle is equal to the opposite side divided by the hypotenuse. And I've written it out here. Sine of theta is equal to opposite over hypotenuse, or opposite divided by hypotenuse. Cosine of an angle is equal to adjacent divided by hypotenuse. So cosine of theta is equal to adjacent over hypotenuse. And then tangent of an angle is equal to opposite over adjacent. So I have tangent of theta equals opposite divided by adjacent, or opposite over adjacent. And these three you absolutely need to remember, because these are three things that are going to come up in many math classes that you take, and we're going to be using them a lot in this class as well. We also have our three other trig ratios: cosecant, secant, and cotangent. Now if you remember, cosecant was equal to 1 over sine. So here, if I have cosecant of theta, which I should write in for all three of these, so cosecant of theta is the reverse of sine. So instead of being opposite over hypotenuse, it's hypotenuse over opposite. We've just flipped the fraction that we had for sine. Same thing over here with secant of theta. So secant of theta is the flipped version of cosine. So secant of theta is hypotenuse over adjacent, and then same thing with cotangent. So cotangent of theta is the reverse of tangent of theta. So cotangent of theta is adjacent over opposite. Now we don't necessarily need to know what these angles are for some of the problems we're doing. So let's go ahead and take a look at the way a problem would be set up. Alright, we're given a triangle here, and we're asked to find a couple of different things. So first off, we're asked to find sine of A. So that means I'm looking at this angle down here. Now we said that sine is opposite over hypotenuse, so I need to figure out which side is opposite A and which side is the hypotenuse. And I said at the beginning of the video that the opposite side is the side that does not touch our angle. So for angles here, the side that does not touch the angle is going to be this side over here that has a length of 6. So we know that the top of our fraction is going to be 6. And the longest side, well, we can just look at the numbers and we can see that 10 is the biggest number, it's the longest side. The other way that you can figure out the hypotenuse is by looking which side is opposite the 90 degrees. Whichever side is opposite the 90 degrees is always going to be your hypotenuse. So sine of A is 6 over 10, which will simplify to 3 over 5. Now if I want tangent of B, now instead of looking at this angle down here, I'm going to be looking up top here. So this is our angle that we're looking at, and we need the opposite over the adjacent. So once again, the opposite side is the side that doesn't touch B, so that's going to be this bottom side down here, that's going to be 8. And now the adjacent side to B is the side that touches B, so 6 or 10, but it's going to be the shorter of the two sides, so that means it's going to be 6. And this will simplify to 4 over 3. Now if we have cosecant of B, this, if we remember, was 1 over sine, or it was hypotenuse over opposite. So in this case, the hypotenuse is still 10, and the opposite side for B is going to be 8. And that simplifies to 5 over 4. And lastly, secant of A, so this is 1 over cosine, or hypotenuse over adjacent for A. And so this would have been 10 for the hypotenuse, and the adjacent for A is going to be 8. So we see that we actually got the same thing here for these two things, and that's okay. That happens sometimes. Sometimes the trig ratios, when working with right triangles, will have two of the same answer for things that were asked, for slightly different things that were asked for. And that's fine. What we see is that's a common pattern when we're working with trig ratios.